Okay, welcome to the first day of Chapter 4. And Chapter 4, we're going to be working with quantitative numbers. And at this point, you should have your notes all set with the date on the top and the right. And you should have labeled it as Chapter 4. Notes are the keywords ready to be put on the side and the summary on the bottom. So in this chapter, we are talking about quantitative variables. So no longer are we talking about categorical. You're going to see lots of numbers and what we do with those numbers and calculations. So the first thing when you're dealing with a lot of numbers, and often when you're collecting data, when I collected data, I had a lot of numbers to be looking at and had to figure out what to do with them. So summarizing the data helps us when we look at large sets of quantitative data. Without those summaries, we don't know what the data is going to tell us. We don't know what story we want to tell. We might have something in our mind, but we want to figure out what is the data going to show us. And we're going to be making a picture. We can't use bar charts or pie charts because those are for quantitative data. So make sure that you've written down somewhere that bar charts and pie charts are for categorical data. We will not be using those with quantitative data. Okay, so quantitative data is coming up right now. Okay. All right, so histograms. So while this doesn't have to do with death per se, it has to do with some natural disasters. So this is the example that the book uses, and so this is the slides that I have to show you. So with histograms, that's what we use to work with quantitative data. And the histogram on the next page is going to show you the distribution of earthquake magnitudes. So how strong all the earthquakes are. So first you take all of the information that you're given and you're going to slice them up depending on the span of values that you have. So these are called bins. And again, I tried to make different colors with the vocabulary words that I want you to know. Okay, so with quantitative data, if we're making a histogram, we're going to separate all of that data into different bins, and that's up to you. We're gonna be piling the data into that. Okay, the bins and the counts in each one have they're given. That's what you're going to look at with the distribution of the quantitative variable. Okay, so that's how the distribution is going to show to you. So here's your histogram of the earthquake magnitudes. So along the bottom, we have the different magnitudes. So ranging from 5 all the way up to 9. And the histogram is going to plot those bins all along the bottom here. Okay. It can also be turned sideways. You're going to see that with a lot of histograms, and then the stem and leaf plots that we're going to look at. Things can be done sideways. Usually you see it this way. Okay, so on the left are the number of earthquakes, and notice that there's explaining the y-axis here and the x-axis, and this is really the title, although it should be written right above it. Okay, so it's going to display the distribution at a glance, and here's the histogram of the earthquake magnitudes. Over how long, it doesn't tell us. But that's all we have. Okay. Okay, so in the histogram, we're going to display, or sorry, wrong thing I wanted to say, relative frequency histogram. That was the next thing. The relative frequency histogram, again, is going to show the percentage of the earthquakes. So of all the earthquakes that happen, which percentage of them landed in these magnitudes? Because you remember that word relative is going to mean that you're finding a percentage of the whole. Okay, so that's what this graph is going to show you. Okay, the next thing is a stem and leaf. I call it a stem and leaf plot. The book calls it a stem and leaf display. It's the same thing. Okay, so it shows the distribution of a quantitative variable, just like histograms do. Okay, so it's just another way to see it, but it's going to preserve the individual values. And the next slide, we have the difference between the two of them. Okay, so first of all, the question is compare the histogram and the stem and leaf plot. What are for the pulse rates of 24 women, what are the differences between them? So the differences that you should notice is on the histogram, we can see overall what this is going to be looking like. We can see that generally speaking, the number of women, there are 4 women between looks like 60 and probably 80 all have there are 4 women that all have that pulse rate. Okay. We look at this as a whole. The stem and leaf, on the other hand, shows us the numbers that are actually here. This side of the stem and leaf plot, this is the stem. And this side are the leaves. Okay, the stem is going to be a whole number, or not a whole number, but a digit. And what happens is the leaves are, in this case, the ones unit. So for example, let's say I'm looking at this row right here. It's really the number 60, 64, 64, and 64. So there are 3 women who have a pulse rate of 64 and 1 who has a pulse rate of 60. In the histogram, we can't see that. We don't know because it all kind of blends right in, whereas here we can see exactly what it is. There are 4 women with 68, there are 4 women with 72, 4 women with 76, 4 women with 80, and 2 women with 84. And that is not shown on these bins because the bins group them all together. If you have decimal places, you would probably break this at the ones unit, and then the decimal places would be after it. A stem and leaf plot has to have a key to be able to explain what is the stem and what is the leaf. Okay, so it must have a key to explain. Okay. So now here's going to give you extra information on how to construct it. So cut each data value into leading digits with the stems and the leaves. The stems are going to be your label for the bins. You only have 1 digit for each leaf. Okay, so somehow we're not going to have 0.8573. You're going to have this so that there's only 1 digit on the right-hand side. The other thing to notice is they go in numerical order. So we have a 0 before the 4s. We have all these 0s before these 2 4s. Okay, so what ends up happening when you make the stem and leaf plot is you make a list of what they are, and then you'll put them in here in the correct order. Another type of graph with quantitative data only are dot plots. And a dot plot is a very simple display. It places a dot along the axis for each case in the data. So here are the number of races that we have, and I should say that the dot plot shows the Kentucky Derby winning times, plotting each race as its own dot. Each one of these little dots is the winning time at a Kentucky Derby. Okay, so there goes all the way up to, must be like 33. You just put the dot for however many races there were. Okay, so let's say we look at 130. So there were 5 races with a winning time of 130 seconds. This looks funny to me. Usually you see it displayed vertically. You don't usually see it horizontally this way. I could also put grades down here, and I could plot how many people got each grade if I wanted to do that. Another option. Okay, so in the thinking before you draw, okay, you need to make sure that you are satisfying this quantitative data condition. So you have to make sure that the data you're looking at, it's for a quantitative variable. You have to know that you have actual units. That will help you also know that it's going to be quantitative data. Okay, so before doing any of these things, you're going to make sure that it's quantitative data. And as we go through this, you will have a sentence that says, the data provided is quantitative because, and something like that. Something that you'll add to that. Okay, right now in this video, we're only going to talk about shape, and then a video over the weekend will have to do with center and spread and more information from chapter 4. So when talking about a distribution, you have to talk about these 3 things. So really you're going to label your answer, making sure that you cover these 3 pieces of data when you're talking about the distribution with a quantitative variable. You're going to talk about the shape, what's happening at the center, and what's the spread of the data. So first we're going to talk about shape. Okay. Does it have a single central hump or several separated humps? I'll talk about what that means. Is it symmetric? Are there any unusual features? So when you're talking about the shape, these are the pieces of information that you want at the ready when you're talking about the shape, because that's going to provide information for you. Okay. So this book calls them humps. You have talked about this in Algebra 2, and I think you did this in pre-calc as well. They're called modes. So does the histogram have a single central hump or several separated? What's several separated bumps? What's going on? So every time you see a bump in the graph, you know that as a mode. And it can have one main peak, two peaks that might not be exactly the same, but they're pretty close to each other, and then it's called bimodal, or three or more peaks are called multimodal. That'll tell you different information about the graph, and we'll spend some time looking at graphs and then being able to describe them a little bit more. Okay, so first of all, when you look at this graph, it is bimodal. There are two humps on this graph, and that will tell us something about it. I don't even know what this graph is about. But there are two pieces right here that stand taller than everything else. So that's something interesting to say about the graph. And you don't need to speculate why or what is happening. You just need to state that it is. Okay? If you have a graph that doesn't appear to have any mode, then we say that it's uniform because there's nothing really changing here. It varies a little bit, but there's really nothing significant. If it was down here and then it went up, or something was standing up taller than the rest of them, then we would say that it had a mode. But right now that it's unimodal. But right now, because they're all pretty close together, we don't really say there's anything special going on about that. Okay? All right, so at this point, you're going to pause and prepare your notes and set all of that, and I will see you tomorrow.